Okay. Hi, everybody. You'll recognize this from our last unit. So I'm going to do a similar example in Microsoft Excel for doing ordinary general annuities. So if you've watched the first lesson, lesson 3.1, you'll notice that there's one major change. And in an ordinary general annuity, the number of payment periods and the number of interest periods per year are not the same. So in other words, they happen at different times, all right? So it introduced two different variables. One was a ratio C, and one was an equivalent rate of interest per payment period, which was labeled as P, okay? That allowed us to use the same equations that we used in Unit 2 for annuities, for future value and present value, and you'll see in a later lesson for finding the payment and the number of payment periods n. The difference was instead of using the periodic interest rate I in the formula, it was replaced everywhere by P. Okay, so a very similar thing happens in Excel. So again, I'm going to go through a bunch of different examples, the same examples that we did in the last unit with just different compounding period and payment period frequencies. So I'm going to do the first question and show you all of the formulas, including the small ones in between for finding periodic interest rate and P and those types of items. When we get further on, I've already calculated those or shown them, and they're the exact same formulas that I used in the first example. The only formula that I will show you is the new one, which would be, in this case, future value instead of present value. So for most of you, when you did your second or your first assignment, you followed this format, which is very good. I want to encourage you to do neat and professional looking spreadsheets. So I'm going to release assignment 2 this coming Friday, June 19th. So when I do release that, you'll be able to follow along with most of it by watching this video, okay? So let's start with the first question, and we're going to find present value. So find the present value of an annuity with payments of $3,000 made at the end of 5 consecutive years if interest is 6% per annum compounded quarterly. So one thing to notice here, payments are at the end of the year for 5 years, but interest is quarterly. So our first item is payment, and remember, these items have to be inputted as a negative value to work in Excel, so negative 3,000. Our nominal interest rate given in the question is 6%, which is 0.06. Now I've got two items here, the number of payment periods per year and the number of interest periods per year. So payment periods, well, payments are only made once a year, right? It says annually in the question, so that means that this value is 1. But interest is compounded quarterly, so that means that the number of interest periods per year is 4. So remember, the ratio, all right, I'm going to actually draw at the same time. So the ratio C is equal to the number of interest periods divided by the number of payment periods. Okay? So in this case, if we're doing it in Excel, that means we press equals and we click number of interest periods divided by, which is the / number of payment periods. So that'll calculate our ratio C. For the equivalent rate of interest, P, remember, P is actually equal to 1 plus your periodic interest rate, and that's the exponent C minus 1. So our last item we need is our periodic interest rate. And remember, the periodic interest rate is the same. It's J divided by M, okay? In this case, that's the nominal interest rate, okay? And that's divided by the number of compounding periods per year, which is 4, right? Because it's compounded quarterly. So that gives us our interest rate of 0.015, which is 1.5%. So now we can add this formula, okay, and we can calculate the equivalent rate of interest per payment period, P. So equals, I'm following the exact same that you would in a calculator, okay? 1 plus, I'm going to select periodic interest rate cell, end bracket. Exponent, remember, I call it the hat symbol. And that's the exponent C, you see over here, so I'm going to click C. And then minus 1, okay? So you press enter. That calculates the equivalent rate of interest P. So from the first lesson, 3.1, you know that that value P is substituted in the present value in all of the equations anywhere where the periodic interest rate was previously. So you'll see that when I do the present value formula. So your length of investment was given in the question as 5 years. So our number of payment periods can be calculated as the number of years times the number of payment periods per year. Okay, so that's the other distinction, because the number of payment periods is different than the number of interest periods. Okay, so you arrive at a number of payment periods of 5. So just like in Unit 2, the Excel formula is still the same, equals PV. First item is your rate. Now remember, this is where it's different. So the rate is your interest rate, and you have to select the equivalent rate of interest, not the periodic rate of interest, okay? Everything else remains the same. NPER is the number of periods. You select that cell. PMT is the payment, so it's 3,000. This one is if you know the future value, okay, you can put it in. If you don't, you type 0. And your last is it the end of the period or the beginning of the period? So this is an ordinary general annuity. So payments are made at the end of the period, meaning you can type in 0, end bracket, and press enter. Okay? So that's the method of doing all of these calculations. Like I said, in the next ones that I do, you'll see that I already have these intermediate calculations performed. They look the exact same as each of these cells that you see up here, okay? So let's look at our second example. Find the future value of quarterly payments of $50 made at the end of each month for 10 years if interest is 8% per annum compounded quarterly. Okay, so I'm going to start typing in our values. Our payments are $50, so negative 50. Remember, one has to be negative. Our nominal interest rate is 8%, which is 0.08. Our number of payment periods per year, okay, well, this is paid at the end of each month, so it's monthly, meaning that value is 12. And our interest is compounded quarterly, meaning we have 4 interest periods per year. So you'll notice that the ratio was calculated automatically. Remember, this ratio would be the number of interest periods divided by the number of payment periods. Remember from our formula up here. So that gives you this 0.33 repeating decimal. Our periodic interest rate was also calculated automatically. It's the same, J divided by M. So J is 0.08, and our number of compounding frequencies is 4. So this gives you an equivalent rate of interest. And the last item you have to calculate is your length of investment. So in this instance, it was 10 years. Okay? So that gives us a number of payment periods of 10 years times 12 payments a year, which gives us 120. So now we can use the future value formula. And again, remember, it's the same as last time, equals FV. Brackets, first is your rate. Just like the last example, you have to select your equivalent rate, not your periodic interest rate. Your number of periods, in this case 120. Your payment, okay, $50 a month. Just like the last question, if you know the present value, you can place it here. Typically you won't, so you just place a 0. And the type, remember, it's payments at the end of each month. This is an ordinary general annuity, so it's the end of the period, meaning you type in 0. Okay, end bracket, and you arrive at your second answer. Okay. Our third one is finding payment when knowing future value. Okay, so in this question, it's what deposit made at the end of each quarter will accumulate to $10,000 in 4 years at 4% per annum interest compounded semi-annually. So again, you'll notice that the compounding frequencies are different. So we'll start with what we know. Okay, it's accumulating to $10,000, so negative $10,000. Our nominal interest rate is 4%, or 0.04. Our number of payment periods per year, okay? In this case, we're making a deposit at the end of each quarter, so that means that we have 4 payments per year. And our number of interest periods per year, it's compounded semi-annually, which means we have 2 interest periods per year. So that calculates now, as you can see, your ratio, periodic interest rate, and equivalent interest rate were automatically calculated. And again, those are the same formulas that I used in this first example. Okay, so you can copy these cells down in Microsoft Excel and they will keep those relationships for you. Lastly, your length of investment in this case was 4 years. So our number of payment periods were 16, right? 4 payments per year times 4 years. So now if we're going to calculate payment, okay, equals PMT. First item is our rate. Remember again, it's the equivalent rate of interest, not the periodic. Our number of payment periods is 16. Okay, select that. Do we know present value or future value? So in this case, we know the future value. So your present value is 0. Your future value is given in the question, $10,000. And again, this is an ordinary general annuity, so payments are at the end of the period. So we type in 0 and bracket. Okay. We arrive at our answer. Looking at the next example, okay, it's the exact same, all right, except we have the present value. Okay. So what payment should be made semi-annually at the end of each period to pay off a loan of $8,000 in 10 years if interest is 10% per annum compounded quarterly? So we know that our loan is $8,000. That's our present value. So remember, it's negative 8,000. Our nominal interest rate is 10% or 0.10. Our payment periods, well, it said the payments are made semi-annually. So number of payment periods is 2. Our number of interest periods per year, interest is again compounded quarterly. So that means it's 4. And like I did in the past, your ratio and all your periodic interest rate and equivalent interest rate are calculated automatically. So again, the same formula as in the first example. So our last input is the number of years, and given in the question is 10. So our number of payment periods was calculated. 2 payments per year times 10 years is 20 payments. So now we use the formula again, equals PMT. We start with our rate. Okay, again, we use the equivalent rate, not the periodic. Number of periods, 20. Our present value, we know the present value, so we select it. And now it asks, do we know the future value? In this case, we do not, so you just place a 0. And lastly, it's asking for the type. And again, payments are at the end of each period because it's an ordinary general annuity. So that means we type in 0. Okay. So now our last 2 sets of examples are for finding N, and then lastly, finding I, the periodic interest rate. Okay. So first, finding N if we know present value. How many quarterly payments of $600 are required to repay a loan of $5,400 at 6% per annum interest compounded annually? So what do we know? We know that the loan is $5,400. So remember, it's negative $5,400. Our payments are $600, again, provided in the question. Our interest rate is 6% per annum, right? 0.06. And our number of payment periods per year, it says quarterly payments of $600, meaning 4 payments per year. And our interest is compounded annually, meaning that our interest periods per year is just 1. Right? Just like in the past, our ratio, periodic interest rate, and equivalent rate of interest are calculated automatically. As long as you type the exact same formula that we did at the start into each of these cells. Okay? So now we need the number of payment periods. Remember, that's equals NPER. Okay. First, it's going to ask for our rate. And again, the difference is you type in the equivalent rate of interest. So you select that cell. Now it wants your payment, $600. Present value. In this case, we know the present value. So you select that cell. Future value, we don't know. So you just place 0. And lastly, it's end of the period, again, because it's an ordinary general annuity. So that means our last number is 0 and bracket. Okay?